In this video we're going to be looking at scatter graphs. So the first question is why? What are scatter graphs for? Well, scatter graphs are used to help decide if there's a relationship between two sets of data. And if there's a relationship, what sort of relationship is there? Now what we're going to do is we're particularly going to be focusing on whether there is a linear relationship. So we're looking to see whether points will make a straight line, and we'll talk about what I mean by that later on. You can have other sorts of relationships which could form points could form a curve of varied descriptions, but that's not what we're interested in. And really what we're looking for is what's called linear correlation. Now, this word correlation it's a fancy word, and it's a sort of a correlation. Okay, so it's how well two things are related to each other. So that's it. It's just a fancy word for the relationship between two sets of data. So, how does it work? Well, you do this with an example. It's probably the easiest thing. So imagine it's end of year exam and all students have taken two papers. So obviously that means that each student will have two sets of results. So the results could be put into some sort of table. So sort of a simple sample of what could be is shown here with just a couple of students A and students B's results. And obviously there'll be a lot more of that. So what we'd actually do is we want to plot this data on a set of coordinate axes, and effectively what we do is we take student A and we use their two values, paper 1 and paper 2, as the coordinates. So in other words, the point 56, 71. And student B, again, the same thing, we look at it as a coordinate 24, 36. So on our coordinate axes, we could plot those points. Now, I've got no scale on these axes. This is just to sort of show you what the idea is going to be. And we literally would put crosses where they would be. Now, normally we'd have actual numbers on there. So if I was doing this properly, we see that here this would be lined up and we'd have the point 24 and 36. And the other one would be the point 56 and 71. Okay, and we can see we go along the corridor up the stairs. And we'd have a whole series of crosses on our diagram. Now, when all the points have been plotted, we can inspect and we can have a look and see if there is any correlation. Now, types of correlation. There are three different situations of correlation that we're interested in. The first one, all the points are going up. We say that's positive correlation. Second one, all the points are going down, negative correlation. And then the third one, the points are all over the place. There is no correlation there. If we can draw a line, a virtual straight line through the points, the closer the points are to making that straight line, the better, the stronger the correlation. So we might define it as this has got strong correlation or weak correlation. So we could quantify it in some way. Now, another thing that we can use are lines of best fit. Now, a line of best fit can be added to reflect the correlation. And ideally, the line should be balanced between all the points and ideally passes through the mean average point. Now, what that means is really you've got, roughly speaking, the same number of points equally spaced either side of the line. Now, it's used to help us make predictions and to make informed decisions. Now, in the example that follows, I will demonstrate how we can do this, how we can draw an accurate line of best fit. So here's an example. We've got 10 pupils taking exams, maths and physics, and we've got all the results. So the first thing we've got to do is got to draw our scatter graph. So normally we'd have a set of axes which are drawn out. Now sometimes, and I put it on here to show this one, it doesn't start at 0 on the vertical axis, it starts at 20, and there's a little zigzag there showing that it's discontinuous there. Okay, so that's just a little trick for shortening the axes. But what I'm going to do is plot the points. So I take them one at a time and I go through and I plot each of the points. And already you can see what's happening with the points, that there definitely is forming a definite looking like positive correlation at the moment. Okay, now the next step we're going to do is we're going to calculate the mean values of each of the maths results and the physics results. Now remember, just remind you, to calculate the mean, we add them all up and we divide by how many there are. So for maths, the mean maths mark, well, the total of them is 447. There's 10 of them. So when I divide 447 by 10, we get 44.7. Similarly for physics, again, we add them all up. And when we add them up, we get 538. And we divide that by 10, and we're going to get a mean of 53.8. Okay, so now the challenge is going to be, what we need to do is we need to plot the mean point. Now to plot the mean point, roughly speaking, we can say, well, the maths mean mark is roughly 45 and the physics one is roughly 54. We can't be more accurate than that. So on my scatter graph, I'm going to plot that point. I'm going to put a circle around it to identify it as being the mean mark. Now what I'm going to draw is a straight line passes through that point and it's got to fit between the other ones as best I can. So just by doing this by eye, looking at it and saying it's about there. So as we said before, the points are clearly going up, so it's definitely positive correlation, and actually the points are quite close to that line, so it's actually quite strong positive correlation. Okay, now how can we use this line of best fit to help us? Well, if you look here, this says we're going to have this mark, we're going to have 50% in the physics exam. What do we expect to get in maths? So what I do is I draw a line of 50% from physics till it hits my line of best fit, and as soon as it hits there, I go vertically down and I can read off a value of 42. So I'm predicting I'd get a mark of 42 if I got 50 in physics. Similarly, if I had 62 in maths, I could draw a line up from 62 and then across horizontally, reading off the value on the physics scale, and that says I'd get about 72. So I'd make a prediction that I'd get 72 given a mark of 62 in maths. Now this process that I'm using here, this is called interpolation. So it's within the points that we know about, and we call this interpolation. And it's quite an effective way of making predictions. The last question says, what happens if I'd scored a high mark, 95% in physics, what would I get in maths? Now if you look, by doing the same as we've just done previously, we end up with a problem because actually we're going beyond the data we know about. It's gone beyond any of the red points that we've got marked on our scatter graph. So we're sort of guessing that this is going to happen. Now it's not far off, so it's reasonable that this might be the case, but we don't know that. So when we are doing this sort of process, if we're going beyond the data we know about, we try and avoid that. This is not a good thing to do. This process is called extrapolation. So we're extrapolating data, we extended it, and we're into the unknown. So really, ideally, we don't use this.